In cosmology now, we have a completely new window for the universe. Until now, we were only able to observe with light. Ever since humans have been around, the only information we have about the universe comes from observing, from looking at things in the sky and essentially seeing light. Gravitational waves open up this new window. Now we can hear the universe as well. And that allows the possibility of studying a completely new range of new phenomena in the universe and things that we cannot see with light as well. For example, the merger of two massive black holes.
So the LIGO experiment uses some very amazing technology. So the collaboration manages to measure some very short displacement, which is much shorter than the typical size of a hair. Okay. So the discovery of gravitational waves not only confirmed Einstein's general relativity, but also allow us to probe some new physics at a subatomic scale potentially.
So gravitational waves are ripples in space-time. But before we understand that, let's think a little bit about what happens in everyday life. For example, if you take a piece of small stone and you throw it in a pond, what you observe is these concentric circles, the waves generated by the stone in the pond. You observe these concentric circles move away from the point that the rock was thrown into the water. Now what happens is that the water does not actually move outwards. What moves out is the disturbance, the perturbation to the surface of the water. And that is what moves around. Now gravitational waves, the medium, the analog of the water, it is what we call the fabric of space-time. It's a continuum of space and time in this four-dimensional world of Einstein's general theory of relativity.
What Einstein really was thinking about was space, three-dimensional space, and time itself being a curved entity. And he found when he thought about space-time this way that there was a completely unique theory he could write down that described the theory of gravity. One of the fascinating predictions of this theory was that one had waves in it, ripples, that would propagate through this space-time and give small fluctuations in the curvature. These are gravitational waves, which the LIGO experiment has been exploring in the last couple of years. And they have now seen 4 confirmed events of very large black holes coalescing.
The field of gravitational waves is a completely new window of looking at the universe. It is a new sense in some regards. Imagine, for example, that you were born and the only thing you can do is just have vision. You can see light. You cannot feel, you cannot smell, you cannot taste, you cannot hear. And the only thing you can do is just, you can see things. And then one day, suddenly you can actually hear. Well, the whole world becomes a completely new place. For example, you cannot see music, but you can hear music. Well, that's on itself, it's a completely new discovery, and it will allow you to hear the world around you. You will be able to hear the sound of birds, the sound of leaves, sound waves that come from the ocean. So it's a new picture of the world. Similarly, in cosmology now, we have a completely new window for the universe.
So the LIGO experiment basically consists of 2 arms with just some mirrors at the ends. And they shoot a laser through these arms. And you know, like water waves, you can get a kind of interference pattern with these lasers. And if the arms shift in length a little bit, that interference pattern shifts a little bit. Now what LIGO sets out to do is to measure a deflection of these arms, and these arms are like 4 kilometers long, so they're pretty long. It sets out to measure a displacement about 10,000 times smaller than an atomic nucleus. So it sounds pretty crazy when you think about it that way.
I think that this suggests the whole universe is kind of connected, like the things happening at very short distance scales are connected to physics happening at much larger scales. So the gravitational wave detection actually shows this interesting interconnection between physics at many different scales and many different parts of the connection between different parts of the universe.